of all, welcome to your notes for today. I hope they help you. But look at your warm-up there. Hopefully you tried it. You can see why we get one is a solution and one is not a solution. But I'm going to show you the video and the rest of the notes here for our new learning target. So remember, the learning target is going to be solve and graph linear inequalities, okay? Inequalities means there's going to be some shading, okay? Like less than or equal to. If the ordered pair produces a true statement, then it is a solution. Don't forget that. If the ordered pair produces a false statement, then it is not a solution. So the first ones are pretty straightforward. Now, I want you to know what's going on here. And I don't need you to do all this right now. Just kind of think about it. Basically, if I said to you to put this into slope-intercept form, like example 2, you should be able to graph a line. Well, then hopefully you can see that one side of the line is up here and the other side of the line is down here. Well, there's a lot of ordered pairs on both sides of the line. What we're going to refer to these ordered pairs is if they come out to be true statements, like if this little ordered pair here, when I plug it in, is a true statement, that means we're going to shade that side. And all of those ordered pairs would be shaded. So there's a lot of ordered pairs that are going to end up being shaded, and there's some that are going to not be shaded. Well, before we even get to that craziness, I want you to just look here, and I want you to go with the simple concept that if you plug an ordered pair in and it becomes true, it is a solution. If it's false, it's not a solution. So that piggybacks off of what we did yesterday. All right, so let's start this. Let me switch colors here. Right in here. So basically I'm going to do 2 times my x value, which is 4, minus 3 times my y value, which is 5, and I'm going to see if that's less than 6. So I have 8 minus 15 less than 6. Clearly that's going to be negative 7 less than 6. This is a true statement. Negative 7 is smaller than 6, so I would say is a solution. This one is a solution. This ordered pair right here is a solution. Okay, then they're saying go ahead and check this one. Well, we do it again. 2 times 3 minus 3 times my y value of 0. And is that less than 6? Well, when you look here, you get 6 minus 0 is less than 6. Is 6 less than 6? And since 6 is not less than 6, that's not a true statement, it's a false statement. I don't put false. These aren't the answers. I say it is not a solution. Okay, so basically if you think this through, and I'm going to tell you about this, one of these points is going to be on the shaded region, one of these is going to be in the non-shaded region if we were to graph it. Okay, example 2, much like the first one, let's just see the scenarios that happen. So y value of 4, and I need to see this work. You need to show me that you understand the concept of plugging in. Remember, this is the x and this is the y. So 4 plugged in will give me that, greater than or equal to 1/2 times 2 plus 3. So just keep that side the same. 1/2 times 2 is really the number 1, so 1 plus 3. This one says 4 greater than or equal to 4. Okay, the key word here, guys, is or. Is 4 greater than 4? No. But it says or equal to 4. Since it is 4, that means it fits the phrase greater than or equal to 4. So this is a true statement. So this one right here would be a solution. Okay, so if we were to graph this line, that would be in part of the shaded region. Okay, then this one here, we have y value of 5 greater than or equal to 1/2 times negative 6 and then plus 3. So we're asking, is 5 greater than or equal to? Well, this right here comes out to be negative 3. Half of negative 6 is negative 3 plus 3. So we have, we have 5 greater than or equal to 0. Is 5 greater than or equal to 0? I would say it is. So this one is a solution as well. Remember, the concept is not that one works and another one then doesn't necessarily. Okay? So that is, that's the first part of your notes. I'm going to stop the video here so the video doesn't get too long, and I'll pick up another one.